Hello, hi, namaste, welcome back. So, the topic of discussion is nanotechnology in agriculture. So, these are the questions that has been asked in UPSC CSC. As we can see, last year one direct question came on nanotechnology's role in agriculture. Okay, and how this technology helped to uplift the socioeconomic status of farmers. It was a 15 marker question, so we have to write in it in 250 words. And in optional paper, two questions have been asked. That is mainly based on nano fertilizer and nano urea, and both have been asked in uh, IFS exam. So this is a potential question in CSC mains also. So let us try to cover this topic. So first is nanotechnology. So nanotechnology means nano means, as we know, nanometers in size, that is 1 to 100 nanometer in size. Okay. So mainly to why this is famous now. So this has been widely used to improve agricultural productivity, nutrient use efficiency, crop protection, and environmental sustainability. So we will see one by one how it is actually helping in increasing soil fertility. So as we have mentioned here, nano clay. So suppose nano clay we are applying. Suppose nano clay we are applying. So nano clay, it increases the surface area, and as surface area is increased, the charge site are also increased. The charge site means the exposed surface, and the charge site are also increased. So as we can say, the CEC, cation exchange capacity, is also increased. So when cation exchange capacity increased, the nutrient, suppose ammonium, potassium, calcium, magnesium, those actually are adsorbed on the surface, so their concentration also increases. So we can say nutrient leaching decreases. So when nutrient leaching decreases, that means from these adsorbed surface, the nutrient are gradually released into the soil solution, gradually released into the soil solution, and the plant can use that nutrient actually, because it is not lost through leaching. So whatever it is released from the charge surface or exchange site, the plant can actually utilize that. Okay, so nutrient availability increases. And another thing is that when actually the surface area is increasing, so what happens, the water holding capacity is also increasing. Okay, so this is particularly useful for drought prone area or degraded soil area. Okay, another thing is that it improves soil structure. Okay, so these things have been written in the benefit: improved soil aggregation, cation exchange capacity, reduces nutrient leaching, organic carbon stabilization. Okay, so some examples, then we will see its role in fertilizer or nano fertilizer. As we know, nano urea is very much famous nowadays. So what actually happens, nano urea say, so when nano urea is actually applied, so first of all, nano urea is not that the ordinary urea is ground into very fine powder. It is not like that. So when urea is actually encapsulated or formulated with suitable carrier material, then nano urea actually form. Then see this nano urea, that is actually nano size, they actually get into the plant through stomata or cuticle. Okay, then they enter the leaf tissue. Okay, from the in the leaf tissue, actually what happens, urea actually is getting converted to, suppose, ammonium or then nitrate. Okay, from ammonium it can be converted to amino acid, then to protein, enzyme, like various plant biomolecules. Okay, so had it been applied in the soil, suppose we are applying soil in the field, it would have face many losses. For example, after urea hydrolysis, okay, so first suppose ammonium formation is there, then suppose ammonia is formed, then volatilization loss can happen. Another thing, if nitrate is formed, nitrate is commonly lost through leaching, denitrification, so many losses are there. Okay, so when urea is directly taken through the plant tissue, these losses are not there. So many times we get very exclaimed that how one bottle of nano urea is equivalent to uh, 50 or 60 kg or more than that of urea per hectare. Okay, so this is the basic mechanism behind it. Similarly, nano DAP also, nano DAP, as we know, so what actually happens for in phosphorus? Phosphorus fixation is common there. Fixation means adsorption and precipitation. Okay, so in when we are applying the phosphatic fertilizer in soil, so adsorption precipitation is common, so phosphorus get fixed easily. So nano DAP is actually helping the plant in to get rid of that fixation in soil. Okay, so here we can see the mechanism. Nano fertilizer means controlled release, reduced nutrient loss, so nutrient use efficiency will be higher, better crop growth, and ultimately higher yield. Okay, so in the note will be provided in the Telegram channel. Uh, Kindly check the comment section and the channel description also for the Telegram channel link. So nano urea, similar thing has been written. 500 ml bottle is substitute one conventional bag of urea as a foliar nitrogen. So this is important. It is actually when we are applying it in the plant actually. So that's why foliar nitrogen source. Okay, not into the soil, so reduces urea consumption and greenhouse gas emissions. Similarly, nano DAP, okay, IPCO is producing both these fertilizers. Nano zinc is also now famous. So the nano nutrient, what actually happens? Another thing, nanotechnology in plant nutrition. Okay, so nano nutrient are absorbed rapidly through leaves and roots, as we have seen in the case of nano urea. So efficient nutrient transport is there, and photosynthesis is improved, and higher biomass and yield. Okay, some benefit of it, this is quite self-explanatory. Then nanotechnology in plant protection. Okay, so plant protection means nano pesticide, okay, nano fungicide, nano herbicide, nano biosensor. Okay, so the nano pesticide, so this is actually doing target specific delivery and control releases there. Chemical requirement is basically reduced, as we have seen in case of fertilizer, the chemical requirement is reduced. So here also the chemical requirement is reduced. So in the one thing, environmental pollution will be lower, and in another case, the cost of cultivation will be reduced. Okay, so yes, persistence here is longer, better adhesion on leaves. Okay, these are benefits we can write. Similarly, nano biosensor, so this can be used for early disease detection. Okay, nutrient efficiency diagnosis. Okay, nanotechnology and its use in precision agriculture. Okay, so we have seen many good things about nanotechnology. So those have been written here: higher nitrogen use efficiency, better crop growth, higher yield, improved quality. We can use this flow chart in the exam. Okay, then economic is the requirement of various chemical, that may be fertilizer, that may be pesticide, is less. So the production cost will be reduced. So higher profitability, again environmental benefit is also higher. Then nutrient losses are reduced, as we have seen. Less water pollution. Okay, so these, when these nutrients are getting leached, so they are actually polluting the groundwater. So when the nutrient losses will be minimized, water pollution will also be minimized. Okay, then lower greenhouse gas emission, improve soil health. Despite all these advantages, there are many limitations. So first of all, production cost is very high. Second is limited awareness among farmers. Okay, another major thing is that need for long term biosafety studies. Okay, so because nanotechnology is getting famous in suppose last decade mainly, so there is very limited long term biosafety study, so it's long term persistence in say soil not fully understood, or we can say uncertain long term effect. Okay. Similarly, there is risk of bioaccumulation, as we have seen here, possible risk of nanoparticle accumulation. So we can say risk of bioaccumulation, risk of bioaccumulation. Okay. Another thing is that when it's we think that the more the nano, more the productivity. That is not true, because the when the concentration actually is increased very much, actually the plant can absorb it easily. So phytotoxicity can be common in nano product. Okay. And another thing is that possible disturbance to soil microbes, soil microbial environment or microbial ecology. Okay. So some other limitation are lack of clear regulation for some nano product, possible risk of nanoparticle accumulation we have already discussed, and limited commercial availability beyond a few product. Okay. So I think if question on nanotechnology comes, we can easily handle, specifically in optional paper or GS paper. Okay. Thank you. Kindly suggest the improvement in the comment section, and kindly find the notes in the Telegram channel. Thank you.